Chapter 10 lists. This is where everything we've learned begins to come together. It's going to be fun. You want to pause. I don't know, are these funny little CS jokes? Maybe. I think the one on the right's kind of cheesy. How do functions break up? The one on the left is not a joke. It is real. It's something that we will all experience. Don't know why the lines are somehow making your program work and somehow be held together, but you don't want to remove them at times. There's always an explanation, but we've all been there and it feels that way at times. Let's start out by writing a program. A simple program. Think of this as just a warm-up, little stretching routine prior to what we're going to cover that is new. It says here, write a program that asks the user how many numbers they would like to enter between 5 and 20. Your program should then read those numbers, one number per line, and you should then find the sum of those numbers as well as their average. And just for kicks, let's pretend we only asked them to enter 5 numbers. We don't want the user entering 20 numbers. So I'll even say, just ask the user to enter 5 numbers, read those numbers one per line, and you want to determine or compute the sum of those numbers as well as their average. So this is using basic loops. May as well do that in at least a main function, right? Everything should have functions. Should be pretty straightforward to code up. As always, we're going to take a look at the problem solving phase and the implementation phase here. But a sample run of the program, as you know, is our starting point. We see here, we ask how many numbers do you want to enter? Let's say they enter 7. Great, please enter those 7 numbers, one per line below, and we read in all of those numbers. I'm going to come back to the sample, but first let's look more and think about more about this problem solving phase, which is not much to maybe discuss, but let's still look at it. So we're going to ask the users how many numbers they want to enter. Let's say they enter 5 or 7 on the last example here. I say 8. We're going to loop that many times. What kind of loop should you use? As we know, we've studied while loops and for loops. If you know how many times you want to iterate, that's when a for loop is ideal. So use a for loop, loop that many times, simply print at each iteration, enter the given number, and then scan that value. You're going to add that value to a sum that you initialized to 0, right? You have a sum variable, you initialize that variable to 0. You're going to add this newly scanned value to that sum at every step of the iteration. Once you're done looping, you've completed the for loop, you're going to print out your sum. You're then going to print out as well the average, which is just the sum divided by the number of values. Should be easy to do. I want to go ahead and code this up. So I want y'all to, if you can, pause the video. I said pause the video. That is incredible. Pause the video. Look at this screenshot. Keep this here. Look at the screenshot of the output, and then try to code this up on your own. I'm going to code it live, but I want you to pause the video. It should only take about 5 minutes, maybe 8 minutes. It's worth doing on your own. Don't just sit here and watch me. Pause the video, try to code this up on your own. You get stuck, come back. But you need to try to do this on your own. Don't just sit here and do it with me. But I'm going to go over to Thani now, and I'm going to do this exactly as it shows. We're going to start here. How many numbers do you want to enter? Well, first let's make a main. So I'm going to call a main down here at the bottom. Let's put some comments. Call our main function, which means we need a main. So define main. And in our main, what are we going to do? Ask the user how many numbers they want to enter. So numbers equals, how about let's say quantity? Quantity equals, how many numbers do you want to enter? Int input, how many numbers do you want to enter? Colon space. Done. Great. Please enter those 7 numbers. Print. Great. Please enter those blank numbers, one per line below. Cool. And now we need to do a for loop, right? So loop, I need to put this as formatted. Printing dot format quantity. So now I need to loop quantity number of times, right? For I in range quantity, what do we need to do? We need to ask the user to enter a number, right? Always look at this sample output and ask yourself what's being repeated. We're repeating enter a number, colon space, and we're scanning that number and we're repeating that. That's what you can see is repeated. Therefore, that's what is going to be inside our for loop. So we're going to, let's just call this num equals and input, enter a number. You see I keep hitting Alt-Tab to go back and forth between these two screens. Enter a number, and we need to do what now? We need to add that number to our sum. So let's put some comments here. Let's put a comment. Prompt user for a number and save to num. Add num to our running sum. So we're going to say sum plus equals num. Notice this is the first time we've used this sum variable, which means what? Oh, yeah, I need a sum variable. Make a sum variable and initialize it to 0. Sum equals 0. And that's the loop. We're done with the loop now. So after the loop is done, we need to, now that the loop is finished, print the sum and the average. The sum of the blank entered numbers is blank. So print the sum of the blank entered numbers is blank. Did I put a period? Nope. Dot format. And we're going to have quantity sum. Formatted printing is so easy once you're comfortable with it. And we're going to print the average of the blank entered numbers is blank. But I put a period on that one. I put 8.14 period on this one, but no period on the one above. I'm going to put a period on the one above. Be consistent, because they are sentences. And let's make this point to F. It does have 2 digits after the decimal, period, dot format, quantity. And now to get the average, we're going to divide sum by quantity. Pretty straightforward. Did I make a mistake? Maybe, and it's okay if I did. Let's do 7. Let's put the exact same numbers. Ooh, I don't like my spacing. I want it to look identical. So I'm going to put a new line before my G, because I notice here that I want this to be spaced, and I want to space after this. So I'm going to put a new line here. I don't want spaces after each of these enter a numbers, but I do want a space before the, I want a space before the T on the, and I want an extra space afterwards. I'll just put the space before here, and that should cover my bases. Let's run that again. How many numbers? I want to enter 7. Let's enter the same numbers. 1, 3, 5, 7. Oops, I hit enter. That was my fault. Run 7, 1, 3, 5, 7. Of course, I skipped 9. 11, 13, 17. The sum of the 7 entered numbers is 57. The average of the 7 entered numbers is 8.14. Super easy to do. That was, again, just an easy little warm-up, a stretch, if you will. Why did I have us do that? Because it's going to lead us into the discussion of this topic, which is lists. So here is the solution shown on the slides, not commented, not using functions, not a very good solution as a result, but that's okay. This is a much better solution that I have here live. In fact, I should probably copy paste this and go ahead and put this into these slides. All right, so through the power of pause, we now have a better solution here in the slides, commented, the one that we just coded up live. Ain't it great? Okay, so that was intended to be easy, as I mentioned, just a little stretch, a warm-up exercise. We want to now use that to guide us into the goal for today, which is to understand lists. So we want to make a slight modification to the problem. And that is, we want to find out how many of those user inputted values are in fact above the average. So here I say program 2. write a program that asks the user how many numbers they would like to enter between 5 and 20. Your program should read those numbers, right? Find the sum, find the average. But after finding the average, now you want to print out how many of those numbers are above the average. That's the only change. This exact same code, but now print out how many of the entered numbers are above the average. That's what we want to do here. And I'm going to go ahead and hit save, and I want to save as and give this a different name. Number above average. So we can have a new program here. So it's the same program, but I've called it number above average. So we want to do the same thing, but after we compute the sum and the average, determine how many of those numbers that the user entered, how many of them are actually above the average. So that's the only difference. How would you do this? I want you to pause the video, spend at least 30 seconds, and think about how you would try to accomplish this, and realize that we first need to scan those numbers from the user, right, in order to compute the sum, in order to compute that average. We need to scan those numbers from the user. And then after we scan the numbers, after we compute the sum, after we compute the average, then and only then do we need to determine how many of those numbers are above the average. What's the consequence there? Pause the video. Do yourself a favor. Pause the video. Spend 30 seconds. And then ask yourself, what's the challenge of doing this? Go ahead and pause. The challenge is what? We didn't save those numbers that the user entered. So if they entered 10 numbers, we didn't save each of those 10 numbers. Well, why is that important, right? All we did is we read those 10 numbers, right, into this variable num. We added that num to our sum, and we continue, rinse and repeat. We didn't save those numbers. So after computing this average, how can we loop back over those numbers to try to determine which ones are above the average, right? I'd love to be able to say if some num is greater than average, then we'll have some count and we'll increment count. You know, hey, we found another one. It's greater than the average. Some number, right? If some number is greater than the average, we found another one, increment our count. But we don't have those numbers saved. All we did is we scanned them, we added them to our sum right here on this line of code, and we didn't save them, right? Because if we want to compute how many of those numbers or count how many of those numbers are above the average, we need to revisit those numbers. We need to somehow have saved those numbers. So a cheesy solution would be, well, let's make 10 variables. If the user entered 10, we would make 10 variables, but we'd have to know how many they're going to enter, right? We could just ask them, enter exactly 10 numbers. We won't use a loop. We would just do this. Forget this whole question of how many numbers do you want to enter. Let's pretend they're only going to enter 10. We could have done this. It would be trash, but we could have said num1 equals enter a number, right? And then we're going to say num2, num3, num4. I'm not going to keep going, but this would be num2, num3, num4. If we had saved each and every number into a different variable, and then after, like we won't even have this for loop. We won't even have it. Now I'll just say sum equals num1 plus num2 plus num3 plus, dot, 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 plus num10. If I then added all of those numbers to the sum, calculated my average, then I could go one by one and check if num1 is greater than average, we found another one, increment count. If num2 is greater than average, I have to make all these long series, these if statements. If num2 is greater than average, increment our count. That would work, right? That would absolutely work. That would be hot trash. That would be a horrible solution, but it would work, right? So I just want you to understand that that would be an option. We could make 10 different variables, right? Is it acceptable? No. Why is it not acceptable? Because what if the user wanted to enter 10,000 values? I wouldn't want to run that program But hypothetically, what if it wasn't 10 variables for 10 values, but what if it was 100 values? Are you going to make 100 different variables or 10,000 different variables? Absolutely not. The easy solution is what we're covering in this chapter, lists. And lists are incredible. Now that we know selection, if-else statements, we know loops, we know functions, we know the basics of Python, this really all comes together now with lists. Lists are super, super helpful. So firstly, I'm just going to show you how we could have updated that program. I'm going to give you a trailer of the movie, if you will, a preview of what lists are. So here's just a bird's eye view. This is a solution of how we could have solved that same problem using lists. Or if I just edit this live, let me come do that as well. I'm going to go ahead and make a list here. Make an empty list. I'm going to call it what? I'm going to call it list 1. I'm going to call it numbers, actually. Numbers equals an empty list. And prompt the user for a number and save it to num. That's fine. We can do that. And I will also add that number to our list. So this is going to be numbers.append num. Just that's what it's doing. We have an empty list. We're adding this number to our list. And then at the very end, we want to keep a count. And we want to loop over the entire list, right? We have all of these numbers that we've read in, and we want to loop over those numbers. So I'm going to say for I in range quantity, and we want to count if numbers at index I is greater than our average, count plus equals 1. And so finally I can print right here. I'm just going to highlight that print statement. The number, I don't like that one. So the number of values greater than the average is blank. And this will be count. And I think that should be fine. Let me put a print statement or an enter here, and let's run this now. We want to enter 7 numbers. They were 1, 3, 5, 7, 11, 13, 15. And of course, I have an error. Average is not defined. Did I delete? Oh, I did not save average. I had actually just called the sum divided by quantity, and that's fine. So I'll just do this. Okay, so I could have actually just right here, I could have computed the average, right? I could have done this and just put average here, and then put average here. Run this again. 7, 1, 3, 5, 7, 11, 13, and 15. The average is 7.86. I feel that's a different number than we had before. What was the average? Come on. What did I do wrong? Not 15. I want to get the exact same numbers. Pardon me. 7, 1, 3, 5, 7, 11, 13, 17. The average is 8.14. The number of values greater than the average is 3. In fact, this is the only one greater, and this one, and this one. Those 3 numbers are greater than the average. Now, what did you get out of that by watching me code this? Probably not too much, and you should not have gotten a lot out of that because we haven't covered it. That's just a bird's eye view of lists. You saw me make a list, and you saw me add values to that list using this append method, where I'm adding a particular value to the list. I then looped back over the list, and I counted how many were above the average. It's super cool, the things and the doors that are going to open now that we are actually learning about lists. So we really have one variable, this variable called numbers, that I defined right here, which is an empty list. In this variable numbers, it's a single variable, that contains all of those numbers. In fact, let me just print right here. Here is, I'll put a new line. Here is the final list. And I'm just going to print numbers. And check this out. Look at what gets printed. So 7, 1, 3, 5. Was it 1, 3, 5, 7? I don't even remember. 1, 3, 5, 7, 11, 13, 17. It was that. And so here, look at the final list. It's one variable that contains all of those values. Again, this is just bird's eye view. We're going to now go into the details. So Python gives us this list class. And this class is a sequential collection of elements. We can store multiple elements in one single variable. And this list class, it contains methods for creating lists, manipulating lists, and processing lists. And what's really cool about lists is they're very similar to strings. In fact, a string is a list. So a string is a sequential collection of those characters, right? So a list can be accessed through an index in the same way that a string can. So if we understand strings, we understand string indexing, string slicing, and those various methods we used on strings, lists are going to be almost identical. So here are some old school ways of creating lists. You can make an empty list, as you see here. I could say list1 equals list with a pair of parentheses. Let me come over here and make a new program. Save. I'm going to call this list basics. I really should have named the other thing something else, so I'll call this just list basics 2. So I could make a new list as follows. List1 equals just list with a pair of parentheses. No one does that, but I'm showing you that's how you could do it. The shortcut way of doing that is saying list1 equals, and you put a pair of those square brackets. That's really how you make an empty list in Python. This was the old school way of doing it. You could make a list with these 3 elements, 2, 3, 4. So we're saying list2 equals a new list with 3 elements, the numbers 2, 3, and 4. Or here we say list3 equals a new list with these elements red, green, and blue. Always remember, this is an assignment. We start on the right side. Our eyes should look to the right. We see this says make a new list with these elements red, green, and blue. Save the address or the reference of that list into this variable list3. Here you can make a list by using the range function. This says make a list of all of the values that will come as a result of this range function. So range 3, 6 will give us the numbers what? 3, 4, 5. If you did a for loop for I in range 3, 6, I will take on which values? The numbers 3, 4, and 5. So here we have a list with those 3 values. And then finally, we could also make a list out of a string. If we say make a list from this string A, B, C, D, it will make a list with those individual characters. So check this out. If I just said list1 equals list of Python, and now if I want to just print list1, look at what we get. We get a list with the individual characters of that string Python. This is the actual list with 1, 2, 3, 4, 5, 6 characters. And if you wanted to print out the length of that list, we could just type print the length of list1. We've used this length function previously, and this will print out here as you see 6, the length of that particular list. Now here I said these are the old school way, old school ways of making a list. In fact, you would not even type the word list anymore. I don't think anyone even uses that. Instead, all of these same lists that we just created can be created using those square brackets. So here's the shortcut or the simpler syntax. Here we just make an empty list. Here we make a list with the numbers 2, 3, 4. Here we make a list of size 2 with the values red and green, and so on. Really, really cool. So we can also see that the elements in a list are separated by commas, and all elements are enclosed within this pair of square brackets. Unique is that also the elements of a list can be of a mixed type. You don't have to have only elements of type integer or elements of strings, right? You can have elements of a mixed type as you see in this list. So in Python, a list is called a sequence type. So why is it related to strings? Because like strings like lists, strings are also a sequence type in Python. They're both sequences. A string is a sequence of characters. A list is a sequence of any element. And Python has many built-in operators that work on sequences, and we've already seen these, which is why this is going to be so easy yet so valuable. So given a sequence S, in this case a list, we've also seen this with strings, S at index I will give you the ith element in that list. We've also seen X in S. That will return true or false if a given value is part of that sequence. Min of S will give you the minimum value of that sequence. Max of S will give you the maximum value. And there's many other operators, and here are several of them. So we've seen most of these, and just as a reminder, if I come over here to the tablet, and let's see, let me click on the tablet, and if I have a list, let's look at the word Python. So we have Python, and I had said, let's say list one equals, and what did I do here? Bear with me. Let me erase this. Let's try that again. List one equals, let's do it this old school way. List Python. What just happened here? What we really now have is we have this string that we've shown you where it's very similar to a string. It's a sequence where we have every single letter has its unique index in this list. Did I really type 6 there? That's fantastic. Erase. And let's come back here, and this is a 5. So this would have been similar. What if I had said, instead of list 1 equals list of Python, if I had just said here, some string s equals Python. What we've seen previously, if I had said print out s at index 3, what would that have printed? That would have printed this h right here, right? S at index 3. This is just strings. This is not lists. This is strings. Print the index 3 of this string Python, and knowing that it's 0 based, so we have 0, 1, 2, 3, and it would absolutely print out the h. Pretty straightforward. Well, here we have a list made up of these characters Python. And if I could print out, for example, if I wanted, I could print list 1. That's the name of this list, right? List 1 at index 3. And what does it print? It will also print the h. So, in fact, you should be thinking, isn't that pretty much the same thing as what we've already learned with strings? And the answer is absolutely yes, which is why I wanted to demonstrate that and draw that out. So what's great about this is we're in our comfort zone. Granted, we just learned strings, but it was super easy. And lists they're both sequences, right? A list is a sequence of any element. A string is a sequence of characters. So these operations are operations that we've already seen most of them, maybe even all of them actually. Let's go ahead and make a list and just run through some of these operations. So here, I'm going to erase this. I'm going to type list1 equals, and I'm going to make a list with some elements. How about we put some even numbers? 2, 4, 6, 8, 10, 12, 14. 1, 2, 3, 4, 5, 6, 7. That's good. And what do we want to do here? We want to check, are certain values in the list? So print 7 in list 1, and we want to print true or false here, comma, 7 in list 1. And when we run this code, it prints false. 7 is not in list 1. Here, if we want to check, is the number 8 in list 1, and that also prints false. Why? The answer is simply because of I changed this from 7 to 8, and I did not change here. We change this to 8, and we get 8 in list 1 is true, 7 in list 1 is false. We've seen that. What about X not in list 1? Here, if I want to say, let me come right here. If I want to say 3 not in list 1, make this a 3, not in list 1, what do you think that'll print? That should print true because 3 is not in list 1. That is true. What about S1 plus S2? Let's make another list. List 2 equals, and let's just simply continue those numbers, 16, 18, and 20. So now we have a total of 10 numbers. If I want to print out list 1, concatenate with list 2, what actually gets printed? Well, check it out. It's going to make a new list of all of those values. It took this first list, it concatenated it, not added it, this is concatenating. It concatenated it with that second list, and it really made a third list of all of those values. We've seen this before as well, where we can have a certain number of copies of those sequences, which is kind of funky, but check this out. If I said list 2 times 4, what gets printed? We're going to actually get 4 copies of list 2. List 2 is 16, 18, 20, right? So here we have 16, 18, 20, 16, 18, 20, 16, 18, 20, 16, 18, 20. Kind of weird. You might think, why would I use that? Well, a lot of times you'll want to create a list with a certain number of values that are all initialized to 0, because we're going to then update those indices. So what if you wanted to have a list of size 100, everything initialized to 0? You could say list 3 equals 0 times 100. And so now if I print out list 3, let's make this 20 so it's easier to print. If I print out list 3, we now have a list of size 20, everything initialized to 0. Super cool to do that in Python versus in other languages. If we want to get the ith element of the list, we can do that. I can print out index 5 of list 1 is, and I'm going to use formatted printing here, dot format list 1 at index 5. Pretty straightforward. What is that value going to be? Remember, it's 0 based, so 0, 1, 2, 3, 4, 5. That will be 12. Index 5 of list 1 is 12. We've also seen slicing. We saw slicing with a string, right? Given a string, if I said s equals Python, we've seen that I could print out s from index, let's just say 1:4. Remind yourself, pause the video and ask yourself, what gets printed here? It goes from index 1, which is the y, to index 2, the t, to index 3, the h, and it stops before index 4. It does not include index 4. So when we print this, we should print YTH, which is what we get. Well, a string is just a list of characters. What about a list of any other sequence, of any element? Here we have a list of numbers. What if I wanted to print list 1 from index 1 to 4, but it does not include 4? So what actually will get printed? It'll be a new list of size 3, 4, 6, and 8. Pretty interesting, right? We can get the length of the list. We can print out length of list 1 is formatted printing dot format length of list 1. And this will print for us the length, which is going to be size 7. Length of list 1 is 7. Interesting. We can get the min or the max value of the list, which is helpful. We can sum the values in a given list. So I can say, let me come right here and I can type the minimum value in list 1 is this dot format min of list 1. And we'll print this, and of course we already know the answer is going to be 2. We can get the maximum value in list 1 is, and this will print out the maximum value, which is going to be 14, right? And then finally, let's print out the sum. The sum of values in list 1 is, and we'll print out the sum, and that will be whatever that adds up to. 56 is 2 plus 4 plus 8 plus 10 plus 12 plus 14 is 56. Now we've also seen, and notice I'm going through this a little bit, not fast, but not with all kinds of detailed explanation, because none of that's new. We've seen all of this with strings. We've also seen, given the string Python right here, can't I just loop over all values in that string? I can say for some character in S, print some character. And what are we going to print? It's literally going to print one character per line on the string. This is just the string Python, right? Here is the string, right here. Well, I'm going to copy this list 2, right here, just so we can see it again within the context of what we're coding. In that same way, I can type for some value in list 2, and we can print list 2. And here we're now, we can print some value, and we're just going to print one value at a time from that list, 16, 18, 20. So it works just like a string because strings are, in fact, a list of characters. A sequence of characters. So this is an example here on the slides showing most of those things that I just went through, looping over the values in the list, printing the length, the min, the max, the sum. You can also sort a list. Now these lists are already sorted up here, so I could make a new list. Let's do this. List 3 equals, let's make it unsorted. And how about 5 to 8? That's good enough. And if I want to say list 3 dot, let's print list 3. Then let's say list 3 dot sort. And then let's print list 3 again. And let's look at those results. Here we have list 3. Now that we've sorted it, this is the result. We could also shuffle a list, like shuffling a deck of cards. You could shuffle a list, which does require the random class. So if I were to type shuffle list 1, this list way up at the top, right? If I want to shuffle list 1, and then I want to print list 1, let me actually print list 1 first. And then if I try to shuffle right now, it's going to shout at me saying, I don't know what shuffle is. Well, here, if I come at the top and I import random, and then I come down here and I type in random dot shuffle list 1, and then I print list 1, notice it's shuffled. Not hard, just you have to know it, right? Random dot shuffle, just like we have random dot rand int, we have now shuffled our lists. And I do want you to see the distinction here on the slides that instead of saying import random, I said from random import star, which is a unique way that we may not have seen. So instead of saying import random, I'll comment that, import random. Here I've said from random import star, which means import every function in random. The value of doing that is I now don't even need to type the word random, and I can just type the word shuffle directly. So if I wanted to do a random number right now, instead of saying, if I want to say random value equals, I would have normally said random.randint 1 comma 10, like to get a random number between 1 and 10, and then I can print that random value. But I would normally say random.randint. Well, because I've already said import all of those functions from random, I now no longer even need to type random before the randint, and I can run it directly. And here I got the random number 10, run it again, I get the random number 2, and so on. Nothing really new here. Lists are new, but the way they work are just like strings. Just to end by showing you something you already know, but just a reminder, how do we access these elements of a list? They're zero-based. We access these elements of a list using their indices. So here's an example of a list, and here is a graphic depiction of that list. Remember, what's saved inside a string variable? It's really an address or a reference that points over to that list of characters. Well, in the same way, what's saved inside my list here? My list is a variable. What's saved inside it? A reference that points over to this list of values. So here, my list at index 0 is the 5.6. My list at index 7 is this 45.45. And finally, the 10th value, there's 10 values in this list. The 10th value is stored at index 9, this value 11123. Pretty straightforward because once again, it's like a string. We can then use those values. We can take two of the values in the list, save it into another index. We can take the value at index 0 plus the value at index 1 and save it to index 0. We can take this 5.6 and the 4.5 and save it to index 2. It's possible, no problem. We can now do other examples. We can loop over the list using using this range function. We've seen that as well with strings. A lot more to cover. I see we're just over 40 minutes. I want to go ahead and stop this now. It's been fun, as always. Reach out, ask questions. Take care, everyone.